Hey everybody, welcome to your lesson on graphing linear functions. In this lesson, we're going to use different methods that will be used to graph lines and analyze the features of a graph. And just a reminder, in a linear function, the graph is a straight line with a constant slope. All linear functions have a y-intercept, and the y-intercept is where the graph crosses the y-axis. If a linear equation has a slope other than 0, then the function also has an x-intercept. The x-intercept is where the function crosses the x-axis, and we're going to look at visuals of both of those. So key concepts of this lesson: to find the y-intercept in function notation, you would evaluate it for f of 0. The y-intercept has coordinates 0, 0. To locate the y-intercept of a graphed function, you're going to determine the coordinates of the function where the line crosses the y-axis. It's very simple, so you just look where your line hits the y-axis, and then you figure out what coordinates they are. Same for the x, except for we're going to be looking at the x-axis. So to find the x-intercept in function notation, we're going to set f of x equal to 0 and solve for x. The x-intercept has coordinates of x, 0. So the x-intercept will have a y-coordinate of 0 all the time. And the y-intercept will have an x-coordinate of 0 all the time. To locate the x-intercept of a graphed function, you just look where your line hits the x-axis. So those are your intercepts. How to find the intercepts. To find the slope of a linear function, you pick two coordinates on the line and substitute the points into the equation. M, which stands for slope, y2 minus y1 over x2 minus x1. And that is a little bit fuzzy. Right here, it's x2 minus x1. And again, m is the slope, y2 is the y-coordinate of the second point, y1 is the y-coordinate of the first point, x2 is the x-coordinate of the second point, and x1 is the x-coordinate of the first point. If the line is in slope-intercept form, the slope is the x-coefficient. So what that means is, I'm going to just make up a number. An equation. 12 equals 3x minus 4. So we've got y right here is 12 equals mx, m is 3, x is x, and then minus 4 is the y-intercept. So it says if the line is in slope-intercept, the slope is the x-coefficient. So the x-coefficient, remember, a coefficient is the big number that comes before the variable. There's only one coefficient in this whole problem, and that is the number 3. The number 3 is your slope. It's the thing that comes before your x. And then the y-intercept, when you're identifying the y-intercept, you have got to make sure that you include the sign that comes before the number. So the x-intercept in this problem is not 4, but negative 4. So common errors and misconceptions: incorrectly plotting points, mistaking the y-intercept for the x-intercept and vice versa. So like really making sure that you understand your axes on the graph, which one is the y-axis, which one is the x-axis. Being unable to identify key features of a linear model, confusing the value of a function for its corresponding x-coordinate. So we're going to do a couple of examples where we're going to figure out what the x-intercept is and what the y-intercept is by plugging in for 0. We're going to do some where we look at the graph. So example number 1 we'll do together in lesson. Number 2 is, given the function f of x equals negative 1/2 x plus 2, use the slope and y-intercept to determine the x-intercept of the function. Before I go any further, the first thing I want to do is just go ahead and highlight what we're looking for. Use the slope and the y-intercept. So again, the slope is the coefficient that comes before x. So this is the slope, negative 1/2, And we're going to also use the y-intercept, which is positive 2. Remember, we have to use the sign that comes before numbers because the sign tells us what number it is, whether it's a positive or a negative number. So we have the y-intercept is 2. That means your x value is going to be, again, it's 10, 0 because right here is your x value. But if you're looking at your y-axis being this line right here, all the way down, your line over here does not go up the y-axis at all, which is why it's 10, 0. Okay, example 3, given the function f of x or y equals negative 4/3 x plus 4, we're going to solve for the x and the y intercepts, and then we're going to use the intercepts to graph the function. Step 1, we are going to substitute 0 for f of x in the equation and solve for x. Okay, so here's f of x. We're going to plug in a 0 here, and we're going to solve for x. In order to solve for x, we're going to move this 4 over to this side, which would cancel. Get my pen out. Minus 4, these cancel. This leaves you negative 4 equals negative 4/3 x. That's just a fraction bar. And then in order to get rid of the negative 4/3, we're going to multiply by the reciprocal. Whoops. Which is going to cancel these guys out. All right, I'm going to start this over. This looks kind of confusing because of where the ink is. So I just want to go ahead and write these in before I solve the problem with you, because I don't want there to be any confusion about what's a fraction bar and what's a subtraction sign. All right, so starting over, we are going to get x by itself in order to solve for the x-intercept. And so first step is we're going to move 4 over. So subtract 4 from both sides. And that gives you this right here once we've subtracted 4 from both sides. And next we're going to divide both sides by, right here, negative 4 over 3. Negative 4 over 3. When you divide negative 4 over 3, remember when you have a fraction and you're dividing, it's same change flip. So you do negative 4 over 3 is really negative 3 over 4. It's the same as multiplying by the reciprocal, which is how you get 3. Okay, so you would have over here on this side, you would have negative 4. And I'm going to go ahead and put it as a fraction over 1 just because we're dealing with fractions, times negative 3 over 4. Now, we notice we can do one of two things. We can say negative 4 times negative 3 is 12 over 4. 12 over 4 simplifies to the number 3. You could have also cross-canceled first. So 4 and 4 cancel. That leaves negative 1 times negative 3, which would be 3. So either way, you get the same x-intercept answer of 3. So now we're going to do the same thing. Similar thinking to find the y-intercept, only we're going to substitute 0 for x in the equation instead of substituting 0 for y. So you're going to start with your original function, which is f of x equals negative 4x plus 3. That is our starting point. Negative 4 Okay, let's put the fraction bar in here. Some of the slides, it doesn't show up. So here's our fraction bar. There's our fraction bar. And I'm going to switch to the highlight tool to point out the steps that I'm speaking about. So we have f of x equals negative 4/3 x plus 4. We're going to substitute 0 for x. So that's the step right here. And we're going to solve for y. So anything times 0 is 0. So this is actually really easy because this whole part, negative 4/3 times 0, cancels to just be 0. And so 0 plus 4 is 4. The y-intercept is 0, 4. Again, a common misconception is with this is when you accidentally reverse it and you put 4, 0. So make sure that you plug the number in the right place, either for x or y, when you're finding your intercepts. Here we go. We've got the first one, which is your y-intercept. Your x value for that is 0. So this one is going to be this line right here is going to be 0, 4. And this line right here is going to be 3, 0. Okay, and that's your x-intercept. Here's your x-intercept, crosses the x-axis, y-intercept crosses the y-axis. Now you draw lines to connect your 2 points, and you are donezo. The next 3 slides are just directions for graphing equations using a TI-83 or 4 or an Inspire. And you're welcome to pull this video up in class just to see how it's done if you would like to do that. Have a great day, everybody.